Let's give a sketch of this polynomial. So I think we have all the tools in our tool belt to be able to do this. Let's think maybe about zeros first. So I would like to write this in factored form. And I think this quadratic here is going to give us two real zeros. I think we can factor this. This is going to factor as x minus 1, x minus 3. And pause the video, double check me on that. All right, this factor here, it's not going to factor nicely, but you can use the quadratic formula to show yourself that the two zeros are plus and minus square root 3. So x minus square root 3, x plus square root 3. All right, and then this factor right here, x squared plus 3, that's not going to give us any more real zeros, right? There's no x value that you can plug in there that's going to give you a 0. X squared plus 3 is too high up, right? Never crosses your x-axis. That's never going to give you a 0. It doesn't give us any more zeros for this polynomial. So we have 1, 2, 3, 4 real zeros. What's the degree? Degree 2, degree 4, degree 6. So if we were to multiply everything out, it'd be x to the 6th plus some smaller stuff. So 6-degree polynomial with 4 real zeros. This factor at the end increases the complexity. It increases the degree, but doesn't offer any more real zeros. Let's go ahead and plot these points on our plane. So the first factor tells me that x is equal to 1 will be a 0. The next factor tells me that x is equal to 3 is going to be a 0. The next factor tells me that square root of 3 is going to be a 0. So something a little bit higher than 1, not quite 2. And the last real factor tells me that minus square root 3 is going to be a 0. So let's think about end behavior now. So we've already counted the degree. This is a 6-degree polynomial, 2, 4, 6. And the leading coefficient, if you were to multiply all this out, there's a 1 in front of that one, there's a 1 in front of there, there's a 1 in front of there. It'd be x to the 6th. So even degree polynomial with a positive leading coefficient means that your end behavior is approaching positive infinity in both directions. It's like x squared. Okay, we haven't talked about y-intercept yet. Let's talk about y-intercept. When are you going to cross this y-axis? That's when x is equal to 0. So p of 0, let's use the factored form. That's going to give me a 3. That's going to give me a minus 3. And that's going to give me a 3. So we end up with a minus 27. Oh, so I'm way down here. I'm off the charts. So let's connect the dots. I give myself that 0 there, and it occurs once in the factorization, so I pass through. I pass through that 0 at square root of 3. I turn around and I pass through that 0 at 1. And then I go way down here, and I have a y-intercept of minus 27. I come back up. I pass through that 0 at minus square root 3, and I join my end behavior. So that's not a bad idea of what the function looks like without a calculator.